Hey guys, how you doing? Can you hear me back there? Excellent. So my name's Ryan with Blue Sky Energy Solar Charge Controllers and Genasun. Primarily speaking though, we're going to talk about Blue Sky. I know it's a little early in the morning, and generally speaking, every time I come out here and I give these seminars, it seems like people come back year after year and like, well, last time I got about 50%, this time about 75% comprehension. It's just going to add up as time goes on. Kind of a informal setting here. If you guys have any questions, go ahead and raise your hand. I'm going to try to cover all the different topics here, from charge controllers to batteries to just about everything under the sun, and just general solar questions at all. So even if you don't have a Blue Sky controller, you have another brand name out there, it still kind of applies to you because solar is solar. How many people have solar on their rigs? Woo! How many people are in float mode by now? Right? I always make a joke, there's two types of people in the world. Those that wonder if they have enough solar, and those that brag about being in float mode by 11 a.m. Right? So, to start off the conversation, we're going to talk about maximum power point tracking, or MPPT, versus PWM style charge controllers. PWM stands for pulse width modulation. Now your average solar panel varies on its output voltage, partially in conditions, but also in its construction. For example, your classic 12 volt solar panel, like your 36 cell solar panel, its output voltage under load will be about 18 volts. That goes all the way up to like your residential panels, those 72 cell panels, and they'll put out about 36 volts under load. Of course, panel temperature, sun angle, dirty panels, that can affect the voltage a little bit, but generally speaking, not a whole lot. Now, a maximum power point tracking controller basically runs your panel at its ideal voltage, and then it does a buck type energy conversion, meaning it's going to lower the voltage but increase the current. So for example, if you had 10 amps coming into 18 volts, you'd have about 13 amps coming out at 12. So volts times amps equal watts. You do the math either way, you're getting all the power from your system. Now a PWM, or pulse width modulation type charge control, basically when your controller's in bulk mode, when it's providing constant current, when it's giving all it's got trying to raise the voltage, a PWM style charge controller basically just connects your solar panel directly to your battery. And when it does that, it's forcing your solar panel to output at your battery's voltage. So now instead of putting out a potential 18 volts, it's putting out 12 and a half. So you're losing anywhere between 20 to 30% of your power just on a standard 12 volt panel, 36 cell panel. Now if you had a 72 cell panel, one of those 24 volt panels, then you're putting out 36 volts, now you're knocking it down to 12, you're only getting a third of your power, right? You're just kneecapping yourself right there as far as your energy production. So really, MPPT charge controllers might be a little bit more than PWMs, but it's worth the investment. You're taking all that time to install it, to use your panel, and you want to be in float mode by 11 a.m., hopefully. And so that's pretty much how that works. Anybody have any question on PWM versus MPPT yet? Don't worry, I will confuse you before the day's over. Now the Blue Sky controllers are very programmable, right? Now a lot of controllers will tell you, oh, this is my flooded setting, oh, this is my AGM setting, oh, this is my lithium setting. Now, we found that even in the same battery types, there's a wide range of their manufacturer's preferred charge voltages. For example, your T105, they recommend a 14.8 volt absorption. Your Deca, 14.6. So it's all over the map. Even your sealed batteries, your Lifeline wants 14.3, your Full River wants 14.7. So it's just, instead of just going, that's what I want, we're going to let you program exactly what you want. And also we get the question, well, what about lithium batteries? Now we'll talk about charging lithium batteries and the multi-stage profile in a minute. But yes, the only thing difference between charging a lead acid battery and a lithium battery is how you want to charge it. And believe me, there's a lot of opinions out there on the best way to charge a lithium battery. I mean, it's all over the map. And it's continually learning, because it's a new technology. Some people would say never fully charge them, other people want a two-stage. So we'll talk about that in a little bit. Now, talking about multi-stage charging for a second. Initially, when your controller is given all it's got, we call it bulk mode, right? In essence, you're actually providing constant current, CC. You might hear some data sheets go CC, CV, and like your battery and your data sheets and stuff like that. constant current is basically given 100% of its output, trying to raise the battery's voltage. Now the first set point used to be called constant, then it was called acceptance, now it's called absorption. So if you hear somebody refer to as acceptance mode or absorption mode, they're interchangeable terms. It kind of sounds like an AA meeting, right? So it's important to get to that absorption voltage. Now with a lithium battery, you normally call it the charge voltage, right? They don't call it, or the balancing voltage. They don't really call it the absorption voltage. And if you look at a lot of battery data sheets, they call it the bulk voltage. So I don't want to have that be confused, because we refer to bulk as a mode. You're in bulk mode. You're trying to raise the battery's voltage. But if you look at like the Trojan's website, excuse me, they'll say, oh, it's the bulk voltage. So if you're looking at your data sheets, you're looking at how to charge your battery, you know, pretty much acceptance, absorption, or bulk voltage are all the same set point. Now it's important to get to that first set point, because battery 101. Now to put simply, when your battery discharges, a coral reef grows on those lead plates. And then when you charge the battery back up, that coral reef turns back into acid, called sulfation. That's normal and it's healthy. Soft sulfation specifically. You know, coral reef grows, coral reef goes back down. Now, you might hear from lead acid batteries that you never want to discharge it past a certain point. Well, you don't want that coral reef to get too big, because it's really much harder to turn back into acid. And then you'll probably hear, you know, you should keep your lead acid batteries charged all the time. Never want to leave them discharged. That's because the longer that coral reef lives on that lead plate, the more it gets hard, and the harder it is to turn back into acid. And so that's just healthy. And you can actually kind of see it. If you guys ever filled up your batteries with water and you look down in there, you can kind of see some white fuzzy stuff on your lead plates if your batteries are discharged. Also, if you guys do the hydrometer and you're checking the acid level in your battery, that's what you're doing. You're just looking at the ratio of water and acid within your battery to make sure that that coral reef is no longer in there, right? Because if everything turns back into acid, then your battery's charged. Any questions on the coral reef analogy? Great. Also, talking about like equalizing batteries. Equalizing a battery is where you bring it into a deliberately higher voltage. Again, that preferred voltage could vary depending on what battery you have. It could be anywhere between 15.5 volts, or a Trojan T105 recommends an astounding 16.2. Woo! Now, as you charge your battery, or you equalize your battery, you guys might notice it gurgles a little bit, right? Especially with the flooded batteries. And that's actually, not only is that a reflection of the higher voltage, but it actually stirs the acid and the water within the battery itself. The acid is actually heavier than the water, and so it can layer inside your battery, and then you get what's called stratification of your plates. The coral reef pretty much just grows on the bottom versus, you know, the whole lead plate, and you don't have as much surface area. So, stages of charging. Your controller wakes up in the morning, woohoo, and it goes up to the absorption voltage. Now, you want that absorption voltage to match your battery manufacturer's recommendation. We talked about that a little bit, where a Lifeline 14.3, Trojan T105 14.8, and it's all over the map. I know most of the batteries offhand. When people call me and say, how do I program it, I can normally rattle them off, but of course you can always contact your battery manufacturer. Now, at some point, your battery's resting voltage is about 12.5, and so at some point, keeping your battery at that higher absorption voltage becomes redundant, right? Because you're not at 12.8, you're at 14 something. That's always going to take some amount of power. So there's two different ways you can make this transition from the higher absorption voltage down to the lower float voltage. Now, a standalone charge controller, meaning just like I have a controller, it's in my wall, that's it. It's just basically going to base it on time. So as an industry standard, 2 hours seems about right. Now, it could need 5 minutes because your batteries are fully charged. It could need 4 hours because your batteries have been discharged for a long time. It needs more time to finish off that last 20% of charge, turning that, the coral reef, the sulfation, back into acid. The other way to make that transition happen is to have a current shunt. A current shunt's this little guy right here, and it goes in between your battery bank and your chart and everything else. So I always tell people, if you put your finger on every negative post of every battery, the only thing touching that finger should be another battery or the shunt. So all loads and charge sources go through the shunt. And that way you can base that transition from the higher absorption voltage to the lower float voltage on the net current reaching the battery versus just time alone. And that's a much healthier and sexy way to do it, because now if your batteries are fully charged and you're in storage mode, it's just gonna say, wake up in the morning, go, I have an absorption. Oh, I'm full, back to float, right? And also that cycling does a good job of making that sulfation off. Or inversely, let's say your batteries were discharged for a long period of time, or you've got a lot of loads going on while you're charging your batteries. You might want to hold it longer than 2 hours. Also, in the old days, they used to think that having a battery maintain the resting voltage, like the float voltage, like a trickle charger, that you could just do that and leave it at 13.2 and your batteries would be perfect forever. Right? Nowadays, it's come to, you really want to bring it up to that absorption voltage on occasion, right? So a lot of times with all the programmability, we have the, automatic equalization, all the voltages can set. So a lot of times with the people have the 3000i and they're parking their motorhome, their moho for the summer storage or the winter storage, depending on what part of the country you live in. I'll say, okay, have it just maintain the float voltage, but every few weeks, let's go up to the absorption voltage for a couple hours. Let's make sure those plates stay clean. Because they will still sulfate a little bit while they're maintaining that float voltage. So a lot of the smart chargers, will also every now and then cycle up and down to that absorption voltage. But for the most part, maintaining the float, because flooded battery has a monthly self-discharge rate of about 12%. So it's just sitting there and it's going to discharge on its own. The sealed batteries, the AGMs, not so much, 2 or 3%. A lithium battery, almost negligible, maybe 1%, maybe 1%. A lot of people say, should I get a lithium battery, right? Now, other than the cost, woo, and also the making sure that your charge controller is compatible with it. Of course, all of ours are. It's really nice to have. Now, the benefits of lithium battery, there's a couple. One, the energy density is much higher. So if you only have room for one battery underneath your step, you can get a lot more amp hours out of it. Also, when you talk about its capacity, a lead acid battery, you really don't want to discharge below 60%, right? So you want to always never get more than 60% depth of discharge. And so that you could equate that to say, and I'm sure you guys know, never bring your battery below 12 volts. I'm sure you guys heard that, right? Never bring a lead acid battery below 12 volts. So that means if you have a 100 amp hour battery, you really have about 60 amp hours to work with, right? Because you don't want to discharge it more than 60%. A lithium battery is more like 80 or 90%, before it just drops off the map. They call it the knee. It looks like a hockey stick. It looks like 2 hockey sticks. It goes like, scoop, really stable voltage, boom, right? Not a lot of warning. But when you have a lithium battery, you also really should have a battery monitor, which incorporates the current shunt. Because unlike a lead acid battery, where you're like, man, I'm at 12.2, my batteries are getting a little low. A lithium battery is going to go, I'm at 12.5, 12.5, 12.5, I'm off. You're like, oh man, So you really want, especially with a lithium battery, you want to be able to monitor that current coming in and out, so you have a rough idea of how much power it has. Also, lithium batteries, unlike lead acid batteries, don't care if they're fully charged. You can take a lithium. Actually, a lot of times, especially on storage, they like to be somewhat discharged on storage. So if you have a lithium battery and you're putting away your camper for the season, discharge it about 30%, 40%, and leave it there. You really don't want to leave a lithium battery fully charged for long periods of time. As when you're in storage mode. Of course, if you're using it and you're out here, you're cycling, yeah, charge it up, discharge it. As far as how to charge a lithium battery, everybody's got an opinion, okay? And a lot of people make some really good cases. So I don't want to dive too much into that, as far as, it's more like you do it how you want to do it, you know what I mean? Of course, I have my opinion. A lot of people would say you never want to charge a lithium battery all the way. You want to charge it up to like 80%, 90%, never to 100%, except like every month or two you want to balance the cells. Balancing cells in a lithium battery basically means you hold it at the charge voltage, or would equate to the absorption voltage, for a period of time. Now, Battleborn will say 1 hour per battery. Personally, I think that's a little excessive. I have other companies that say about 12, 15 minutes, anywhere between 14.2 to 14.4 would be ideal. Any questions so far? Everybody's waking up? Okay. Talk a little bit about temperature compensation. Lead acid batteries like to be charged at higher voltages or lower voltages, depending on how hot or cold they are, right? Now, everybody spends a lot of money on your batteries, spend a lot of money on solar, and everything like that. So I really do recommend for, less than 30 bucks, you put a temperature sensor on your battery connected to your charge controller. That way, when your batteries are cold, they'll automatically get charged at a higher voltage, and when they're hot, automatically a lower voltage. And there's a good amount of temperature compensation. I got a call one time, and like, Ryan, my alarm's going off my rig, my batteries are over 15 volts. I'm like, how cold is it? Where are your batteries? Well, the battery's underneath, and it's, minus 5 degrees Celsius. I'm like, did the math? I'm like, yep, that's the right voltage. That's what it should be. We do have settings on our controllers. So in his situation, we just set the max, charge voltage to 14.9. So we just put a ceiling on it. So it's still the temperature compensation. His batteries weren't being treated perfectly given his environment, but it's still, going real well. Any questions? All right. I heard he got warmed up yesterday from a solar talk. Really did a pretty good job. Trying to think of more stuff. Yeah.
I have one question going back a little ways to lead acid. You say equalize at 16.2 volts, which
the Trojans, yes,
the
16.
P105s.
Yeah.
So what kind of do you need to shut everything off? Because that's pretty high voltage for equipment, isn't it?
I mean, the only people I find, he asked, like, at what point does high voltage damage a rig? Now, I don't want to speak for all electronics here, right? But generally speaking, most automotive stuff is rated to all the way up like 18 to 32 volts. The only people I've ever found that got really sensitive are people in the ham radio community. They tend to have very sensitive equipment, and they're sensitive over voltage and higher voltages. But I've never heard of anybody being damaged by equalizing their batteries. I agree, and even I called Trojan, I'm like, really, 16.2? And they're like, yeah, 16.2. I'm like, okay, Now, when you're equalizing your battery, everybody might go back like, I want to equalize my batteries, now I know what I'm doing, right? I found that if your batteries haven't been equalized in a long time, or perhaps they haven't charged the correct voltage, that they can be a little stubborn to get up there. So I had a guy, he's got Trojan T105, they're 3 years old, and he had the voltage way low to begin with. And he hit cook, right? He's like, go for it, 16.2. And he's pumping 30 amps into his batteries, or 20 amps into his batteries. And it's like, Ryan, I've been trying for 2 days, and I can only get my batteries up to about 15.8 volts, right? And that's it. That's all they're going. They're gurgling out of water. They're just not going. Like, great, set your equalization to 15.7. So batteries, as they get sulfated, they can be, hesitant or resistant to getting to that higher voltage. Now, of course, the sooner the better. Let me show of hands. How many people think you can equalize AGMs? Well, that's none of these things. I'm not saying you can or you can't. Now, the problem is AGMs are sealed, right? They're sealed batteries, and as you equalize a battery, it generates heat and they can bloat. So I'm not saying people should go back and equalize their AGMs, right? At the same time, for example, Lifeline AGM, they have a little vent on it, and they give specific parameters for reconditioning. You don't call it equalizing on an AGM, you call it reconditioning, right? And they give parameters. Lifeline will say 15.5 for up to 6 hours. I've had other people that say, a half an hour equalization charge on an AGM is a healthy thing, they say. I'm not, that's a scary thing, just because I don't want you to ruin a really expensive battery bank. But I have some people, especially with the Lifelines, they say they want to do a half an hour every couple weeks, just to make sure the plates stay clean. The principles of sulfation and reconditioning, equalizing do still apply to AGMs, but that's one of these things. I've had a lot of people with like full rivers where he did like a half an hour every day, so it didn't get heat, and they just boom, 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 boom. They did it for like 2 weeks, and next thing you know, his batteries really got bad. Now, a lot of times when you say, how do I need, so I'm not saying equalize your AGMs, that's definitely a political topic. If you have a lifeline AGM, they say you don't normally have to do it unless your batteries did severely discharged or haven't been charged in a long time, fully charged in a long time. But that's, when it comes down to like, I've got to buy new batteries or do something, then you might consider a half an hour, if it's between throwing away your batteries or giving it a shot, you might consider giving it a shot. That's up to you. I didn't tell you to do it. don't take me to the bank on that one. Now, a lot of people say, how do I know I need new batteries, right? Like, how do I know my battery's getting soft? Everybody here has batteries in their rig. How many people have, by the way, just out of curiosity, how many people have forgotten to fill up their water and ruined the battery that way? Yeah, at least, you guys are actually more diligent than most. You know what I mean? Like, there's also two types of people in the world. People that check their battery fluid levels every month on the 1st, and those that go, my what? Now, one way to tell your lead acid battery if it's getting soft or it's getting old is you look at its average voltage while discharging. That's at least how I tend to do it. Of course, hydrometer is a nice way to go, but if you have a sealed battery, obviously that's not an option. But if you notice, with a modest load, let's say 5 amps or something like that, when you first buy that new battery, it's like, oh man, that thing's at 12.7 volts the whole time, Fast forward that same battery 7 years later, oh man, it's like 12.2 the whole time. And so you can just judge your average voltage while discharging. That's one way to tell, just basically the health of your battery. Also, the equalizing, you'll see that springs back. Man, I'm averaging like 12.4 volts while discharging. And then you run this 8-hour equalization cycle, and then next thing you know, oh, I'm at like 12.5 average while discharging. So you can actually see, how it's going. I would like to say, just here in Quartzsite, we've got a couple, basically we got 3 favorite people. Everybody know Brian Boone got solar installed? Anybody got? Yeah, I love his work. Anybody here get their solar installed over at Solar Bills? Yeah, Solar Bills, greatest. And Discount Solar? Yeah. So, I mean, those are my 3 favorite installers here in the neighborhood. So if you guys you have any questions, obviously I'm here to help. But if you need more solar, or you guys need more resource as far as solar, Solar Bills, got Discount Solar, and of course Brian are always here to help. They do impeccable work. I'm also pleased to announce we've got Bluetooth. Woo! So Blue Sky, I have a demo I'll be happy to show you. It should be for sale in a couple months, but we've got the app done. We're just ironing out a couple bugs. This right here is our Bluetooth accessory. It basically just clicks into your RG11 IPN network, and then it does everything from seeing what's going on, but also data logs. If you buy an SD card, you can plug it in there. It automatically does all the data logging, and it graphs out everything you've done, and it's super, super cool. We try to make it as feature rich as we could possibly squeeze in there. So nowadays, everybody's smartphone, you want to see it. You want to sit around the campfire and say, man, how many amp hours am I charged? We're like float mode. You can have a raffle like, where's your float mode.
At night you're not charging.
Right.
You're on a fire at night, you're going, oh, it ain't doing shit.
Right. But if you had the IPN Pro remote, you could look at your state of charge as well. You could say, oh, my fridge is drawing 10 amps right now. That's another nice thing about. I've had a lot of people with the current shunt and our IPN Pro remote find parasitic draws just because they have the shunt installed. And actually, one of the trickiest parasitic draws I've heard is the leveling pump, the leveling motor. Even when it's not on, I've heard it can draw several amps, even when it's not running. So if you guys are ever looking for parasitic draws, I've had a few customers come over that and have problems with that. Yes, sir. I have a switch. Look, if it's not connected to the battery, you can't draw power. You know what I mean? And battery disconnect switches are always a good idea. You know what I mean? I don't want. That's more of a motorhome thing. I don't want to dive too far. That's not really my cup of tea. But parasitic draws happen. Another good reason to have solar, right? Because that's always going to maintain your batteries. Also, as far as batteries go, the depth of discharge is really important. Now, if you're cycling your battery down to 12 volts, up 12 volts, that battery is not going to last very long. If you're only cycling like 20% like this, it's going to last a whole lot longer. Because the less that coral reef, the sulfation, grows on those lead plates, the longer it's going to last. Yes?
So, this is charge controller.
Yeah.
Question. When my panels were installed, before we put them in, you see the 19 volts coming out, right? So now, all I can see coming in on the panel now is like 9. Is it because I have a PWM?
Maybe. So what he asked is, like, originally when he got the panels, he could see about 19 volts, right? And then now that he has it connected, his voltage is much lower. You said about 9 volts.
Yeah,
Now, on the troubleshooting side of life, on a solar panel, you always have 2 voltages. You have your open circuit voltage, or your VOC. That's how I take my panel, I put it in the sun, I look at its voltage. That's your open circuit voltage. And then you also have your voltage under load, or your volts max power, your VMP. On average is about 18 volts at STC conditions. Now, STC conditions, and I'm circling around your response. Now, STC conditions never happen. You know, the standard test conditions, right? That's where you got a panel, the sun's perfectly overhead, you're in Hawaii, there's not a cloud in the sky, and it's somehow only 25 degrees Celsius, and it's cool, right? Room temperature. And that never happens. So a lot of times, other panel manufacturers will give you NOCT, normal operating cell temperature specifications, PTC, which stands for PVUSA test conditions, or now the newest one is NMOT, nominal module operating temperature, right? So more like real life expectations. You can only expect about, and generally speaking, 70% of your rated output in real life. That's just one of those things. Now, as far as your question, I'm making sure that we're not confusing amps and volts. Because a lot of times on a charge controller, for example, ours, depending on what you're looking at, it'll tell you your input current, but not the input voltage. But as a rule of thumb, whenever I'm troubleshooting, if your input voltage is lower than 15, you have an input problem, right? There's really no conditions that should take a standard 12-volt panel at 18 volts max power, VMP, and no reason that should ever get below 15. You know, even people in Arizona, where they can quite literally cook an egg on their solar panel, their input voltage is going to be about 15.2. Now, on that note, what causes input issues, right? Where are the main causes of panel input problems? Panels, generally speaking, don't go bad. You know, they're rated like 25 plus years. They last, at least the rigid ones, last forever, right? The flexible ones, you know, not so much. You're pretty good. If you get 5 years, 7 years out of a flexible panel, you're probably looking pretty good. Of course, not all flexible panels are created equally, right? There's the cheapies, they run about $2 a watt, all the way up to like the Sol Bean panels. They'll run you about $1,200 for 100 watts, right? But you can stand on it, jump on it, and have a lot of fun. You know, that tends to be more the marine industry where people start doing these, kinds of things. I think personally, on a price point, on quality, I really like the SunPower panels. SunPower actually makes all the cells, and they get different batches of these cells that solar cells, and they make a really nice flexible panel. But there's several others out there that are fine. If you do the flexible panel, or if you guys like remote flexible panels, which is great because you just put it under your bed, I would recommend you mount it to something. Flexible panels are great and they do flex, but if they're going wooga 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 in the wind all day, they'll develop microfractures in the cells and they're going to fail much sooner on you. For example, I troubleshoot a lot of people and they have boats and they have like a cloth bimini on a marine application, and they lash it down at the top of the cloth bimini and it's going like this, all day in the wind, and it doesn't even last a year. I'm like, same guy mounted a piece of, it doesn't have to be metal, it doesn't have to be wood. You could even use like the fiberplasty, the advertising medium for like poster boards. Yeah. Coroplast. Yeah. But like Coroplast. I don't know, fiberplasty. But yeah, that way it's not continually flexing. Now another, other causes of issues are on the input side, fuse holders. Oh, I hate flexible bladed fuse holders. For the last 3+ years, I've been doing product support for Blue Sky, 1 to 2 times a month. Every month since I started this job, I have a customer have a failed flexible bladed fuse holder. We're talking wiggly wire, one of those plastic boxes, wiggly wire, right, with the automotive fuse in it. Those fail all the time, and fail in a way that's really hard to figure out, because it's not like it's blown, right, but all of a sudden you get this like 2-volt drop or 3-volt drop on this flexible bladed fuse. And I'm not saying they're all bad. Blue Sea, now Blue Sky, Blue Sea, the marine manufacturer of a lot of components, makes a great one. Little fuse makes a great one. So I'm not saying they're all bad, but it's definitely a thorn in my side when it comes to troubleshooting. And then the most common cause of failure, 95%. That's a big number. 95% of residential panel failures, because they don't really do like studies on motorhomes and mohos because everything's unique, is mismatched MC4 connectors. Now an MC4 connector, I can show you an example. Every solar panel you get has got those waterproof male-female click-in connectors, right? And you would think in an industry that they'd all be compatible with each other. Shoot, they seem to clip right in real good to each other. The problem is, nope, it's up to each individual manufacturer to make their own tolerances to abide by. It's not like there's a third-party regulatory that says, oh, you qualify as an MC4 connector. And every solar panel you buy, just about, is going to come with MC4s already attached to the leads, but they don't give you a little baggie with the other ones, with the mating pair. And so that's another really common cause, at least once a month. Brian, my controller's broken. It's not charging. They always blame the controller. I don't take it personally, right? They always say the controller's broken. I'm like, maybe, but, do me a favor. Let's do some troubleshooting first, because 9 out of 10 times it's not the controller, right? Of course, anything electronic can eventually fail. But yeah, mismatched MC4 connectors are really not that good. If you're going to use MC4 connectors, buy some nice ones. Make sure the male and the females match up with each other. Like get Renogy's or whatever. Like, whomever you want to buy, HQSD. There's a ton out there, but make sure the male and the females are from the same manufacturer. Or else that will catch up with you later in life. May not be the first year, it might be 5 years down the road, but it will most likely catch. 95% of panel failures, and that's a huge number. So I'm a big fan of junction boxes. I'm a big fan of solder and heat shrink. But some applications, especially where you've got these remote panels and you just want to plug it in, something like that. Okay, that's fine. There's a time and a place for MC4 connectors, and I'm not saying they're all bad, but just be aware of that. Another thing, one more trick, right? Now, when you charge your battery, you always want to size your wire appropriately, right? And we'll talk about series versus parallel, the great debate here in a second, right? But you want to size your wires appropriately. Now, on the troubleshooting side of life, one trick I often pass along to customers, and they didn't know that their multimeter could do it. If you take your multimeter and you test the same polarity wire, the same, both on red, but you test it at 2 different points, it'll tell you the voltage difference between them, the volt drop between those 2 points. So let's say, for example, you were trying to diagnose if you had a bad fuse holder. Like, why does my charger say 14 volts, my battery's at 12? I'm like, well, you have some resistance in there, right? First thing I'm looking at is the fuse holder. And in that situation, if you put one probe on one side of the fuse holder, the other probe on the other side of the fuse holder, both to positive, if it says 2, Bob's your uncle. That's where your resistance is. Now, you're always going to have a little bit of volt drop. As an industry, you want to keep it under 3%. That's just a rule of thumb. Of course, the less the merrier, right? But you want to keep your volt drop under 3%, and just as a rule of thumb. And then also, a lot of times when people guess the wires, they do this and that, I'm like, yeah, but remember, you're only going to get about 70% of your rated output from your panel, on average, especially if they're flat mounted, right? So you don't need to, when you're gauging your wire and how much output current you're going to have. Of course, you're looking at your voltage, your panel voltage, and you're looking at the distance, but I'm like, you can derate at 30%. You don't need to do STC conditions because they're never going to happen. The only people I've actually found that get STC output are people in Alaska. Go figure. Because they mount their panels vertically under their eaves, so between the low sun horizon and the snow deflection, and their panels being super cold, that's the only people that seem to actually get up there and get close to STC specs. Any questions? Good crowd. Okay, the great debate. Series versus parallel, right? Now, when you combine an array, right? When I mean array, combine multiple panels together. Just like a battery, you know, if you string it together, you'll double the voltage, current stays the same. If you connect all your positives together, all your negatives together, you're going to double the current, voltage remains the same, right? Now, when you combine them in parallel, basically the lowest voltage will dominate. Kind of like when you connect two batteries. If you got one full battery and one dead battery, right, and you connect them together, it's going to pretty much reflect your lower battery voltage, because the voltage kind of being pressure is going to dump into the other one. And that's kind of true with solar panels as well. So if you've got two panels, they both have a potential output voltage of VM or VMP of 18 volts at that moment, and or one's got 17, one's got 18. You connect them together, the 18 is going to try to feed into the 17 a little bit. So you can combine different wattage panels together. You just want to try to keep their output voltage under load within about 5 volts of each other. So you can take a 200 watt panel, 18 volt VMP, and a 100 watt panel, 17.5 volt VMP, put them together, they're going to work just fine in parallel. Also, when you do combine different panels together, you want to keep in mind that you want the same basic construction. You got monocrystalline and you got polycrystalline. I'll touch on that in 1 second. But they both, monocrystalline or polycrystalline, track a little differently with the temperature. Now, when you put panels in series, the lowest current dominates. So, for example, if you've got, and the current as listed on your panel is the IMP, amps max power. So let's say you had one panel with 5 amps IMP and another panel with 7 amps IMP. When you connect them in series, you're down to 5. It's definitely going to bottleneck it. So you can't mix up different panels in series of different current. Now, which is better? Now, there's arguments both ways, right? Now, the thing is, if I take that panel, I can do an experiment. If it was here in the sun, I could show you. But if I look at that panel's output voltage, my little 12 volt panel back there, which is powering this stuff, and I put my hand over it, I cover a cell, its output voltage under load go from 18, about 16.5, maybe 17, it's going to drop a little bit. But if you look at that panel's energy production, it's putting out 5 amps, you put your hand over it, it's down to 2.5, 50% reduction, right? And so when it comes down to an array, now, and so partial shading, when it comes down to an array and partial shading, you know, parallel always wins. I mean, it's always going to win. No doubt about that. Now, because if you have those two panels in series, right, and they both have 5 amps potential, and you put your hand over one and knocks it down to 2.5, you knocked your buddy down to 2.5 as well. Now, there are some caveats on that. Some panels have bypass diodes. So if you put your hand over it, it's not gonna drag down its buddy, but that panel itself is still going to be sucked down, so, or taken out of the loop as the power flows around it. And so I'm not saying which is better. Now the counter argument is people say, well, in order to charge, your input voltage has to be higher than your battery voltage, right? Now different controllers have different margins. Ours, any higher, right? Any higher. If your battery is at 14 and your input voltage is 14.1, we're still charging, right? But when you're looking at the energy production, I put my hand over the one. I'd rather lose 7% versus 50% of my array's production. I mean, that's just how it wins. Now the counter argument is, okay, well when it's cloudy out, right, and it's raining a little bit. If I take my two panels in series, then they're going to have a higher voltage, so I'll still be charging when conditions aren't ideal, right? When they aren't optimal. Now the truth is, right, that is true, right? Point to that guy. He gets some brownie points. But at the same time, you'll notice if you ever look at your input voltage on your panels, or the output voltage of your panels, input voltage to your controller, even when the sun's just on that, I mean, you're getting a terrible angle, sun's really bad, it's about to set, your panels still have higher the battery voltage, right? The other, positive thing I'm saying about putting your panels in series would be wire gauge. To keep we talked about keep your voltage drop under 3%, right? True, you do need bigger wires to keep that voltage drop, but a lot of that's depending on your distance too. Like your average solar panel wire, double jacketed stuff, so that it, is resistant to UV rays. It tends to, 20 feet, 15 feet maybe from your controller. So really, 10 gauge, 8 gauge tends to be fine. It just depends on how many watts of solar you have on it. And it's just an efficiency thing. So if you have an array, like when you guys have these arrays where like the foldable ones sitting way out where, you know what I mean? You're about 30 feet away from your rig by the time you get to the controller. Yeah, series might be a little bit better for that. It just depends on your particular application on the series versus parallel. Any questions? I would like to mention that all of our controllers can be integrated in a master-slave relationship, so you can have multiple controllers with independent inputs. Let me right back to that real quick before I have series versus parallel. It really depends on like how you're camping. If you're camping out here in the desert all day and you've got a flat roof, you could probably get away with series if you wanted to. But if national parks, one tree hanging over, or you've got an air conditioner popping out and you don't want it to cast a shadow on one corner of your solar panel, parallel is going to win, generally speaking. So most of our controllers try to gravitate around parallel connections versus series, just because we want to win that way. Because we know partial shading is a fact of life. Now we can have multiple controllers network together in a master-slave relationship, and so you could have, for example, all the panels in your front of your roof on one, on one controller, and all the other ones in the back of the roof on another controller. So if you pull in or back into a spot and there's a tree covering you, that shade isn't going to take down your entire array. Also, it's pretty popular and common to have a slave set up for your remote panels, right? So you have these two controllers together. Now they're going to optimize their independent arrays, their respective arrays, their respective arrays independently, but they're going to cooperate as a single unit, meaning your displays are going to reflect the gross output of all the controllers of the network. And if you have a current shunt installed or whatever, they're going to go through the different charge cycles based on the net current. You only need one battery temperature sensor. But I have a lot of people that have remote panels. What they'll do, they'll install a slave controller, and they'll have it permanently installed, and they just have like an Anderson plug or an SAE plug and their pump out port or something like that. So when they get somewhere, they just fold out their panel, plug it in, and the whole charge controller still operates as a single unit, and even though this is being optimized independent of this one. Any questions?
How do those communicate through like a Ethernet cable?
No, on each of the charge, you guys found that IP network, how they're coordinated. On each charge controller, there's a little terminal block A and B. So you daisy chain A, B, B, B together. So you just take any twisted pair wire. A twisted pair wire is like a Cat5 wire, or you can buy just a pair, because if you just have a regular wire at any kind of distance, it can act like an antenna. They're EMI, RFI interference. So by having it twisted or heliocoiled around each other, it won't act like a radio, and everything's going to cooperate a lot better together. And that goes for the current shunt as well. So the current shunt operates because it's monitoring the known resistance between those 2 points. So 10 microvolts equates to a 10th amp of current. So we're talking 0.00001 volts equals a 10th of an amp. And so when you're monitoring such a fine voltage, you can't have any interference at all. Any questions? I'm trying to think. I don't think I'm missing anything here. Genasun. So, Blue Sky Energy, everybody's familiar with. By the way, Blue Sky Energy was founded back in 1998. We pretty much brought maximum power point tracking to the market commercially. People were doing it like NASA and stuff like that. but it was originally called RV Power Products, and then it transitioned to Blue Sky Energy because we didn't want to just do RVs, we're doing boats as well. Genasun charge controllers, they're no bells, no frills, no bells, no whistles, but probably the most efficient controller out there in the market. It tracks the MPBT at about 15 times a second, which is why it's so popular in the marine community. But as far as like this community concerned, the GB10, the Genasun GB10 is a really nice, not that expensive controller for your portable panels. Most flexible portable panel kits come with PWM style charge controllers. And so why do I want my 100 watt panel to be a 70 watt panel, right? Doesn't make any sense. You're just chopping your leg off from the input voltages. So a lot of people will use a slave on the Blue Sky, or you can, if you just want to replace your existing controller on your portable panel, that's a really good idea. Also, Genasun manufactures a boost type charge controller. What that does is it takes your panel output voltage and it increases it to charge the battery with a nominally higher voltage. So for example, you could take a 12 volt panel and charge up your golf cart with it. You can put a solar panel on your golf cart and it'll charge it up, multi-stage charge profile and all that. So that's really cool. I've got some people, they say, well, I used to plug in my golf cart, but not anymore. I just put a panel on the roof and it's always charged. So not as popular in the RV community, but definitely an option out there. Really popular with the golf carts and really popular to replace your existing PWM charge controller if you had like a portable kit.
Electric bikes. I'm just looking at sign electric bikes. Where would you mount it on an electric bike?
Well, you see the panel back here, right? The charge controller is only about this big,
Right.
and it's waterproof. It's IP68 waterproof,
Oh, I see it.
just like your iPhone. So you can dump it, you can put it in the water, it'll go down, I think it's like 10 meters for 30 minutes, right? As far as the waterproof rating from my ETL and everything like that. I had a guy that does autonomous marine vehicles with it, and he's like, Ryan, we had one of our units go down to Davies Jones locker. We brought it back up and fired up, and your controller works great. I was like, I wish I could say the same thing for the lithium batteries, but the controller works great. I'm like, that's the kind of product support I like to hear. Like, you're like, hey, I just want to call up and say, great job. I'm like, awesome.
No, I'm just looking at that bike. I guess you put an extra wheel and a solar panel on the back.
Yeah, he's got an electric hub motor right here. So that's his motor. That's that. The controller is probably stuffed. It could be stuffed anywhere, and then the controller itself it doesn't have a very large footprint at all. But this is also part of the Trans-America or Trans-Asian race on the Genasun. So they actually go from, it's like France to China or something like that. They just go all across the Eurasia, and pretty much everybody's got the Genasun because nobody else can boost charge voltages like we can, right? And have the reliability and have the efficiency. And there's not even a heat sink on the Genasun controllers because we don't waste heat, we don't waste energy. I've had people test it and they're like, how does it do? I'm like, magic, just magic, right? My watts in are just like my watts out. Yeah, 98.5% efficient. It's just setting a standard. That about concludes it. I'd like to welcome you guys, all those that have Blue Sky. If you want a new hat, got some hats for you. If you want to see, I'd love to show off our new app. So I would like to show you what we're doing. That'll be available. Yeah. Well, I'll show it to you. You're going to have to, the Pro Remote, right, to get the app to the Bluetooth accessibility, you're going to have to get our Bluetooth device. We haven't finalized the name yet. You could call it our Bluetooth dongle. I've got an example right here. It's hooked up and I can show it to you. We're just finishing up like all the injection molding to get the final cases just 3D printed, and a couple of bugs on the firmware. Yeah, it's compatible with any current Blue Sky product. The older ones like the Solar Boost 50, which were all analog, not compatible with that. But anybody that has any Blue Sky product manufactured since 2006, it'll be compatible. You simply click it right into your RG11. So you look at the back of your Pro Remote, you have that phone cable, RG11. It's just go clicked in, click, right there, good to go. And if you want data logging, you just buy a little SD card and pop it right in. And that way you'll just automatically all the data logging. And so I'd love to show that off. We're really excited. It's kind of a long time coming on the Bluetooth, but pretty cool, and I'd love to show it to you because I've got the app on my phone, and it's active, it's working. So.
Do you have any idea what the price point's going to be on it?
Yeah, it won't be terribly expensive. No, I mean it's not a monster. But no, I have no idea. That's totally not my cup of tea. You know, we'd always say that's a Stefano question. It's like, that's a marketing guy's question. I don't really deal with numbers, but $100, something like that, nothing major. We want to really keep it competitive here. And any new controllers that we roll out, it'll all be integrated. You won't have to get that Bluetooth dongle separately. We're going to revamp the 3024 controller, have slightly higher input voltages, and then we're coming out with a larger controller, like a 100 amp version, which is going to be not only a cat to the bank, but it's going to be nice.
No,
It's really nice. But I mean, lastly, we did come up with another product, our Waypoint, which is kind of like our universal communication module on crack. It's it's not that popular in the RV community just because it's pretty expensive, but it does everything from all your data monitoring and logging, hooks up to the cellular network, uploads everything to clouds, and can also connect into your CAN bus on your rig if you have and all that. It's pretty nice, and that's, I'd be happy to demo that as well, but a little pricey too. You know what I mean? I think that a lot, as far as this crowd is concerned, the RV community, the data logging of the Bluetooth device, Bluetooth accessory, is going to pretty much do everything you need to do on that. You don't need to receive a text message to say, or an email that says, hey, your battery's a little low, that kind of stuff. Yes, sir.
The GV10, I see it says lead. Does it handle lithium too, or no?
Yeah, different. Yeah, all the Genasun controllers can handle anything, right? But it's all in the firmware. So depending on what model you get, yes. You know what I mean? So
Okay, so you have to order it accordingly.
Order accordingly, correct.
And you mentioned that was good for portable panels.
Right.
Would you suggest a shunt in that system, or?
No, I wouldn't say. I mean, the shunts, no, because when you get he asked, would you recommend a shunt with a portable panel, right? Now, always, if you can incorporate a shunt into your system, it's always a nice, because you never want, once your batteries get to that higher absorption voltage, right, we want to have them stay there the ideal amount of time. Now, the way that works, the reason for that is, if you look at a battery's construction, you've got the lead plate, and then you've got the secret sauce on the lead plate, right? Everybody's got their own chemistry, their own paste that goes around this lead plate. Now, it's a kind of a 50-50 thing. Whenever your battery voltage is at that higher voltage, you're using up some of that secret sauce on that lead plate. So the higher voltages tend to degrade that coating. At the same time, you need to get to that higher voltage to keep the sulfation off that plate.
Right.
So ideally speaking, to answer your question, I'd say if you already have a charge controller, and for example, let's say it's a 3000i or a 3024, one of ours, right? And it has a shunt, you would be better off having a slave to that system, right? Because now because they're cooperating as a single unit, it's going to base that transition as they operate a single unit based on the readout of that shunt. Now, if you just have a portable ZAMP panel that has a PWM controller on it, and you want to upgrade to an MPPT controller, do I think it's necessary to have a shunt there? Not really, because when you're going to be using that, most likely you're going to be actively cycling your batteries.
Right.
You're going to be using the heck out of them. It's not like you're in storage mode and this panel's going to be sitting there holding your batteries at their max voltage all day, every day, unnecessarily because they're fully charged. You're probably not going to get to float mode until 3/4 through the day anyway. And so I don't think it's that much of a deal breaker.
Yeah.
You know what I mean?
Yeah, that's true. And you can be disconnecting it when you don't generate anyway.
Right.
You're not using both, right?
Yeah, so I don't think it's much of a deal breaker to have it on on a portable panel setup. Any other questions? Everybody ready for some more coffee? Everybody's brain hurting yet? Well, excellent. Well, thank you guys very much. It's been a pleasure talking to you guys. I'll be here. I'll showing off the dongle and everything like that. So have a good morning.